Hello guys, welcome back. Today in this video tutorial I will be taking care of a new sensor, that is ADXL345. Now let's have a look over the website, that is controleverything.com, and here we have to search for this particular sensor, as you can see, and here we go, and let's see what's it specifically. As you can see, it's a 3-axis accelerometer, and these are some of its more prominent features which you can see. Also you can have the ability to purchase from this, as you can see, add to cart is here. Next, I will be interfacing the accelerometer ADXL345 with an Arduino Nano, and Arduino code is required. So go to resource tab, Arduino code sample is here. Now you can now download the code sample as zip file from here. Also you can have the code from github.com, and the repository there is control everything community. Now we need to set up some hardware connections for the working and the interfacing, and let's see what we got here. In the hardware connection setup, first of all, the requirement is an Arduino Nano, which you can see on my screen, and this here is an I2C shield. It's available on the website controleverything.com, and the real reason we are using this shield is to make easy connections with other I2C devices. So for that, gently place this Arduino Nano over the I2C shield, and then we are done. The next part is to provide the sensor, that is the accelerometer ADXL345, and this here is a connecting cable. Now make the connection among the sensor and the cable, and make sure that the brown wire of the cable should be connected to the ground terminal of the sensor, and for the I2C shield we have to apply the same rule. Then we have to apply the power, and for that we require a mini USB cable just like this, and then gently insert it over here, this power jack. So we are all done with the connections. Let's have a look over the Arduino code and let's interface it with the sensor. So we are on the interfacing section part, and here we have to log into github.com to get the C code, and here first step is to search for the repository, that is control everything community. Here we go, and here type in for the sensor ADXL345, and this is here, and this is the Arduino code. Let's have a look over the instructions first. As you can see, we have first of all to download and install Arduino software ID on our local machine, and the steps to install Arduino are provided on this very link. It's arduino.cc. As you can see, you can download the software from here just like that, and you can run it on Windows, Mac or Linux. It's your choice. Now do it carefully. After that, get back to the code, and here you can notice it's a .ino extension file, and in the code you closely observe that first of all we have included wire.h library, and we have defined the address, that is 0xF3 of the sensor. Now in the void setup function, we have initialized I2C communication as master and initialized serial communication with the baud rate equal to 9600. Then in the writing section part, we are going to select band rate register, that is 0x2C, and we are going to send the command for normal mode output rate, that is 100 Hz, and it's 0x0A. Then we are going to select power control register 0x2D, and then we are going to send the command for auto sleep disable, that is 0x08. And the last writing command, we are going to select the data register, that is the data format register 0x31, and we are going to send some commands. As you can see, it's for self-test disabled 4-wire interface, full resolution, range equal to ±2G, and it is 0x08. At the end of this part, we have a delay, as you can see, and then we have a void loop function in which we are going to select the data register 50 plus I, as you can see, and from this register we have a for loop which runs 6 times, and we are reading and requesting 6 bytes total for acceleration data, as you can see, for X, Y and Z perpendicular axis. Here comes the conversion part of the data, which is according to the details provided in the datasheet for ADXL345, and at the very end of our code we want to display our output data onto the serial monitor, which is the acceleration in X, Y and Z perpendicular axis. Let me tell you, these are the raw values, which means they can be positive, they can be negative depending upon the acceleration of the sensor at that particular time. So we are done with the code. Now what do we require is to have a look over the working. Let's have it. Now in the working part, in the environment, first of all we have to copy this entire code of the sensor, and then we have to open up the Arduino terminal, and in this Arduino terminal the first step is to paste the entire code and then save it. by the name ADXL345 for the reference, and then we have to verify and compile the code, and then after it's done compiling we have to upload the code. It's uploading. It's done uploading. Now we have to check for the output, which means we have to open up the serial monitor. So you can see we have the acceleration in all the three perpendicular axes x, y and z, and the values are almost constant, which means there is no motion in the sensor. But when I try to move the sensor, you can see the acceleration changes in all three perpendicular x, y and z axis. Yeah, that's correct right here. So these are the values, and this is how the sensor responds to the Arduino code along with the Arduino Nano. Now let's have a look over the benefits and the applications regarding this sensor. The ADXL345 is a small, thin, low power, 3-axis accelerometer with high resolution measurement up to 16 plus minus 16G. Digital output data is formatted as 16-bit 2's complement and is accessible through either a SPI 3 or 4 wire or an I2C digital interface. It measures the static acceleration of gravity in tilt sensing applications as well as dynamic acceleration resulting from motion or shock. So these features make it very useful for a wide range of applications such as handsets, medical instrumentation, gaming and pointing devices, personal navigation devices, fitness equipment and a lot more. This sensor can be purchased from the website controleverything.com, and you can also get the code from there. Go to resource tab and you can download the code as a zip file. You can also have the code from github.com, and the repository there is Control Everything Community. In the end, I hope you enjoyed this video and you understood, and in case if you have any queries, you can reach us on controleverything.com and you can post your comments on the community page. For blogs and articles which are relevant to this sensor or video, you can go to instructables.com, and if you want to subscribe more video tutorials just like this, go to our YouTube channel. In the end, I hope you enjoyed this video and have a good one yourself. Thanks a lot for watching.